refrigerant switches. These two things thread onto copper lines. The low pressure one will come from somewhere around here. There'll be a line that comes down. And then there's just a little Schrader valve where that switch will come with threads. That switch gets put on and the two wires come out. The high pressure switch will be so actually right at the compressor just about. So right about here will come up. Have its Schrader valve and then have its switch. And all these things, these two things operate on rise and fall. These are R4 switches. So the low pressure switch is set at 135 and 93. So if you're running and it's normal operation, it's above 93, and the air temperature is dropping, and that pressure is dropping, it hits 105 and hits 100. When it hits 93, that switch right here will kick out. Similar to this, where if the water pump goes, it kicks out. When the refrigerant pressure right here drops because the air is not warm enough, which will occur somewhere around 45 degrees. Depends on humidity that day, depends on temperature of your water. If the water is only 55 degrees in the spring when you open up, that's not going to help it. So it might actually shut off at at a higher air temperature. When the water is warmer, you can cheat and run at a colder air temperature. But it's all going to be in the range of. The rule of thumb I give over the phone is if it's below 50, it might shut off. It could run as low as like 42 or 45.
I've heard even 52.
Yeah, it's hard to tell because if you're in a shaded area, where's your thermometer telling you it's 52?
Right.
How accurate is that thermometer telling you it's 52? And if the weather on the TV, says 52, that's right wherever it's at. But it's not watching temperature. The key thing to know there is it's watching refrigerant pressure. The pressure is indirectly influenced by the heat of the air. You'll find that there's a certain point in the morning in the spring and summer where at a given installation, if it's something where the sun hits it at 9 a.m., that heater warms up enough to go on to 9:15. When other heaters in the neighborhood are still in shade, they're not going to keep on until that.
Yeah, it's funny because I've had that same scenario. I've had people in the same neighborhood.
It's too.
Hey, my neighbor's is turning on, but mine isn't.
Is it in the sun? Yeah, is it in the sun?
Yeah.
Is your water warm out there?
Yeah. So now I have an answer.
So it's hard to say a specific temperature.
Right.
Something we're looking at going into is instead of a pressure switch, is a pressure transducer where it will actually tell us what the pounds per square inch or what the PSI is, just like as if you had gauges on. With the pressure transducer, then we'll know exactly when it's about to freeze, and we'll be able to run to exactly the point where ice will be uniform. The whole purpose of that cutting out is to stop. This takes about 10 degrees of heat out of the air, or 12. So when this air is coming across and it's 45 degrees, the air coming out on this side is 35, 34, 33. And as soon as it hits 32, you're going to have ice crystals in these fins. It'll start actually up here at the coldest point, but you'll get them in these fins, and as soon as the ice forms in the fins and the air can't flow across it, then you're not getting any heat transfer. Your efficiency shoots to the floor, and there's no point running. So that's why it switches out. It's the same thing on the high side. Let me finish with this though. So it'll cut out at 93, and your system's at low pressure, typically because of air. Other things can influence that, but we'll get to that later. When the air temperature gets too cold, it shuts off. And what you don't want to happen, as soon as the system shuts off, this side's running at high pressure, this side's running at low pressure. As soon as the system shuts off, those two pressures will equalize out for the next time it starts. You want the pressure to be equalized when the compressor starts, and they go to high and low. So when it shuts off, they go like this naturally. And what you don't want to occur is low pressure switch cuts it out, and it rises and kicks back on. And then low pressure kicks out, and you go into a cycle of on, off, on, off. So that switch won't actually kick back in until 135 psi, a number which is above an equalization number. That'll make sure that it's actually warm enough to start. You may have a little bit of cycling in the spring when you're starting up and your air is cold and it warms up really quick, and so you might have some, it might cycle once or twice. Your customer typically won't even notice it. They're in the house making dinner, they don't even know it's, they just think it's running, shutting off, naturally. If you get a situation where it cycles more than once or more than, you're having cycling all day long and it won't stay on, maybe we are low on refrigerant. Now it's not warm air, it's not cold air causing the pressure to drop on this side, it's actually lack of refrigerant in the system, and the system pressure is dropping enough to kick it out. So when it kicks on, it doesn't go to its normal running high and low, it goes like this, and that's low enough to kick it out. So it's low in refrigerant, it's not an air situation. That's something you'll see with when you have gauges on it. You'll know what the air temperature is, and you'll know what pressure to expect to run at that air temperature. If you hooked it up in the morning when it's cold out, 60, 50 degrees, and your refrigerant, you turn it on and it's running, and it's hovering just above it, well, that's to be expected. If it's 80 degrees out or 90 degrees out, and you turn it on, you have your gauges, you look at the gauges, and it's down at like 100 psi, right at the point where that's going to kick out, well, that's not right. It should be up way higher because the air is way warmer. This pressure is going to rise and fall with this. The high pressure switch works kind of the opposite of this. This one shuts off when the pressure hits a certain point and then doesn't turn on until it comes back up to 135. Was it 93, 135? Yeah. This one works the other way. It is, I think it's 405.60. I can't read that one. Find out the number for sure when we get there. It's kind of smudged off, but that one will shut off when the high pressure side gets to 560, if that's what it is. And it won't. This switch won't re-engage and close back up until it goes down below 400. So this one shuts off when pressure is dropping. This one shuts off when pressure is rising. And then neither one will reset until they come back down. So it doesn't turn on at 93, turn off at 93.
Very rarely have the high pressure would give us trouble. It's only the
Very rare. What would do that is hot water. As opposed, like cold air causes this, hot water would cause this. And the high pressure switch is higher than the thermostat. So you'd have to have a thermostat failure, because the thermostat's going to cut it off at like 104. The high pressure switch probably won't kick out until the water's like, I'm going to say about 120 or 130.
Yeah, it's going to take a while to heat that water up to 100.
Right. You can do it in a spa quickly, but not in a big pool.
Right.
Other things are at play there.
Right.
The low pressure switch is more of an efficiency thing, and also to stop freezing. The high pressure switch is like a secondary safety.
Right.
Overcharging could also cause that. If you put too much refrigerant in, that'll cause that. So it's kind of like an over-the-top safety. But still, to know the principle behind it.